I'm standing here beside one of the most significant exhibits at Brooklands Museum. It's the Vickers Wellington bomber, known as R for Robert. But I'm not actually here to talk about the aircraft, but rather to talk about its unusual structure. You can see from this section that has been left uncovered that it's actually constructed of a number of curved intersecting sections that curve round the fuselage and give it the most immense strength, as well as making it extremely resistant to accidental damage. The origins of this unusual structural form lie in the design of a large British airship of the 1920s called the R100. It was created by a Vickers Armstrong subsidiary called the Airship Guarantee Company, and its chief designer was a young structural engineer named Barnes Wallis. A major challenge for any airship designer was how to contain the huge bags of hydrogen gas and transfer their lifting force safely to the airship's main structure. Wallis chose to solve this by adopting a concept known as geodesics, a Greek-derived name for the shortest line between 2 points. He applied it to the curved forms of the gas bags, which resulted in a net-like mesh of wires which took the lifting force and transferred it evenly to the airship's hull. In spite of the technical superiority, the R100 was denied turning this excellence into commercial success by the fatal crash of a second British airship, the R101, which had been designed and built under the direction of the Air Ministry. This disaster signalled the end of British airship production, and in 1930 Barnes Wallis transferred to Vickers' aircraft business at Brooklands. He was appointed Joint Chief Designer with Rex Pearson, and together they started to design a series of bombers. As these were required to carry a large payload over a long range and at high speed, Wallis believed that geodesics, or geodetic construction as he called it, might provide a strong but light structure to optimize their performance. The first application of geodesics, or geodetics, a biplane, was not a great success, but the next, a single-engine monoplane bomber called the Vickers Wellesley, entered service with the RAF in 1937. By then, a much larger twin-engined aircraft that would become the Wellington had also flown, but its complex geodetic basket weave structure was proving difficult to build in quantity. Fortunately, the works manager at Brooklands, Trevor Westbrook, was able to devise some ingenious machines to produce the curved structural members efficiently out of strips of aluminium alloy. By this means, more than 11,000 Wellingtons were built by semi-skilled workers throughout the Second World War, both at Brooklands and elsewhere. Although geodetics did indeed provide a light but very strong structure, it was still covered in doped fabric, which was unsuitable for the post-war high-altitude pressurized aircraft. These required a more robust light metal covering, and the resulting aluminium stress skin construction heralded the end of Barnes Wallis's geodetic concept.